Welcome to This Explainer. Today we're documenting a high-stakes battle happening right on your desktop. For years, the story of artificial intelligence has been completely dominated by massive cloud-based models. But there is a seismic shift happening literally right under our noses. It's an all-out hardware war between AMD and NVIDIA, and it is bringing enterprise-scale AI directly to you.
So let's start with a really critical problem that every single professional faces today. Think about it. Every time you ask a cloud model to review a contract or analyze a proprietary document, your prompt creates a dependency. Your data literally leaves your machine and just vanishes into someone else's infrastructure. You're basically crossing your fingers and trusting someone else's security and servers. Now, for the average user, sure, that arrangement works fine. But for professionals, yeah, it often just doesn't cut it.
Act 1. The invisible threat. By 2024, the entire AI industry had become completely obsessed with basically one customer, right? The cloud data center. Everyone just assumed that if you wanted serious AI, you had to connect to the cloud. But outside of Silicon Valley, an invisible threat was brewing for professionals who actually needed control over their own knowledge bases. Look at this stark contrast. Cloud AI gives you incredible speed, absolutely, but you're paying for it with subscriptions and total data dependency. On the flip side, we have local AI. The model runs entirely on your machine, no uploads, no internet required. Your procedures and your engineering calculations stay completely local, locked down safely in your own memory.
And, for these professionals, engineers with proprietary designs, lawyers with confidential claims, architects doing vendor evaluations, uploading sensitive documents to a public server is just a complete non-starter. This created a massive market opportunity that the industry honestly kind of ignored at first. Because if you're an engineer working on, say, critical oil and gas facilities, your company absolutely prohibits uploading those proprietary designs to a public AI. They demanded AI that worked locally. But initially, the big players thought this market was just too niche, too fragmented, and frankly, too technical.
Act 2. The challenger's masterstroke.
Well, while NVIDIA was busy looking at data centers, AMD looked directly at the professional's desk and saw a completely different problem to solve. AMD realized that the future of the local AI market wasn't about cramming more capability into a server rack. It was about maximizing capability per desktop. They figured out that local AI didn't actually have a compute problem, it had a memory problem. And their answer? The Strix Halo platform, coming in hot with a staggering 128 gigabytes of memory. Because the reality is, the biggest obstacle for professionals wasn't just raw speed. It was actually fitting these giant AI models into memory in the first place. If a model doesn't fit, it literally cannot run. So in 2025, when AMD launched Strix Halo with up to 128 gigs in a compact desktop form factor, that single number changed absolutely everything.
And here is the real game changer: unified memory. This architecture changes everything, allowing massive models, we're talking up to 200 billion parameters, to actually run on a standard desktop. See, traditional systems separate CPU memory and GPU memory, meaning data is constantly having to shuffle back and forth. It's inefficient. But AMD went with one single massive pool of LPDDR5X memory. It's shared seamlessly across the entire system without those constant data transfers or strict VRAM ceilings.
Because of that insane 256 gigabytes per second of memory bandwidth, the workflow is just unreal. On the Ryzen AI Max Plus 395 platform, an engineer isn't just running a local AI assistant, they are simultaneously running heavy CAD software, doing stress analysis, keeping Outlook and Teams open all at the exact same time, all on a single, thermally efficient machine, and it doesn't even break a sweat.
I really love this quote. Productivity is not measured in tokens per second, it is measured in work completed. That right there anchors AMD's entire philosophy in this fight. It's all about giving professionals practical tools to actually finish the job securely. When your proprietary documents are completely locked down on your own machine and you can run your heavy engineering software right alongside your AI, that is true productivity. It's about getting the work done, not just chasing flashy benchmark numbers.
Now, to pull this off, it's not just a standard CPU and GPU anymore. There is a third processor in the mix, the XDNA 2 NPU, delivering roughly 50 TOPS of dedicated AI performance. So what does that actually mean for you? Well, by isolating those ambient, everyday AI tasks like background noise cancellation or real-time transcription to the NPU, those 40 massive GPU compute units are left entirely free to handle the heavy lifting of your complex local AI models. It's a brilliant division of labor.
Act 3. The Titan Strikes Back.
Come on, you didn't really think the biggest AI company in the world was just going to surrender the desktop without a fight, did you? The professional AI community had stopped asking how many CUDA cores does it have and started asking, can my model actually fit in the memory? That shift completely upended the industry's assumptions. So NVIDIA realized they were fighting on AMD's turf and they pivoted fast. Initially, they had responded with the DGX Spark, which was technically amazing but heavily Linux-based. Honestly, it felt way more like a specialized developer tool than an engineer's daily computer. But then came RTX Spark. Windows-based, unified memory, total AI-first design. The message was loud and clear. NVIDIA decided a professional desktop market was just too important to ignore.
But here's the thing. NVIDIA's ultimate weapon isn't actually their silicon. It's a massive software moat they have been meticulously building for 2 decades. 20 years. Anyone can try to copy hardware eventually, but a deeply mature software ecosystem, that takes generations to build. And that deep optimization is absolutely their strongest weapon in this entire war.
Just look at the stats on their CUDA ecosystem advantage. We're talking about 6 million developers across more than 200 countries, with over 900 CUDA-X libraries. Almost every single AI model and framework out there is optimized for NVIDIA first. Whether you're accelerating quantum computing or building the next big AI breakthrough, CUDA is simply the default standard. Most developers build, test, and optimize for NVIDIA before they even think about anyone else, making it incredibly difficult for a challenger to swoop in. So, the crucial point is that we're witnessing 2 totally different philosophies clashing over the exact same professional users. On one side, you have AMD banking heavily on massive unified memory and raw hardware capability so you can run whatever you need locally. On the other side, NVIDIA is leaning hard into an unmatched software ecosystem and deep developer optimization. Put simply, AMD believes memory is the future, while NVIDIA believes software acceleration is the future.
Resolution: the token speed illusion.
Okay, to really figure out who wins this war, we have to dismantle a massive myth about AI performance. If you're used to a cloud model spitting out 120 tokens per second, seeing a local AI generate just 6 tokens per second probably feels agonizingly slow, right? But here is the secret. Local AI is intentionally not competing on sheer speed. Professionals should never buy these local systems expecting cloud-like responsiveness. They're buying them for a completely different reason.
And here is that reason. A 30-second answer that is factually correct and completely private is infinitely better than a 3-second answer that is wrong or worse, leaks confidential company data. For a professional, running a highly capable 30 billion parameter model locally at 6 tokens a second is exactly what they need because confidence and privacy absolutely trump sheer speed. An engineer doesn't get paid for generating tokens quickly, they get paid for being right. Larger models give you better reasoning, better context retention, and better technical accuracy. Being able to actually fit those massive models locally, that is the real victory here.
Now what's next? AMD is playing it a bit quiet right now, and that's because they know their software ecosystem is still maturing. But just look at this hardware roadmap. We're already seeing industry whispers about the near-future Gorgon Halo, pushing memory up to 192 gigabytes. And after that, the Medusa architecture, featuring Zen 6 cores and LPDDR6 memory. AMD knows time is on their side. They are just waiting for the software world to fully adapt to this massive unified memory approach.
So let's bring it back to you. If you have a budget of, say, $3,000 to $4,000 and you are investing today, your choice really boils down to your daily workflow. If you spend your day doing engineering document analysis, knowledge management, or running local LLMs, AMD's Ryzen AI Max Plus 395 gives you an incredible balance. But if you're actively building AI pipelines, generating video, or leaning heavily on those established CUDA frameworks, then NVIDIA's RTX Spark is going to be extremely attractive for you.
This arms race has finally brought true enterprise-grade AI right to your desk. And it's doing it without compromising your data. The fascinating truth of documenting this local AI war is that both companies might actually be the right choice, just for completely different users. So the ultimate winner here isn't AMD and it isn't NVIDIA, it's you. You finally have the power of personal, private AI infrastructure. So, as we wrap up this explainer, I'll leave you with one final question to ponder. Whose infrastructure will you build your future on?